All right, so here we have a dog kennel owner needs to build a dog run adjacent to one of the kennel cages. See the figure below. And it says the side walls of the run are to be cinder block. So here and here are going to be cinder block, which cost 50 cents per square foot. And then the outer wall here is going to be chain link, which costs $2.75 per square foot. Now, local regulations require the walls and fence to be at least 7 feet high and the area to measure no fewer than 120 square feet. Now, determine the dimensions of the dog run that will minimize the cost but still meet all the regulatory standards. So it has to be that, and these walls have to be 7 feet tall. All right. So maybe what we should do is let's do one here. So optimization. Okay, what is that? Well, we want to minimize total cost. Okay. Now, what is our input? Well, we're going to have a cinder block and we're going to have chain link fence. So let's call maybe this one, this time, let's call that one X and let's call this one Y just because we want to be different this time. So let's say Y is equal to the block wall and X is equal to the chain link wall. Okay. All right, so that is what our optimization is. They've already given us the diagram, so we've done that. We just labeled it X and Y, which is what we needed to do here. So this is part two. Okay. Now part three, we need to go and we start plugging in things that we know. All right, so part three. Now part three, a lot of times I don't really differentiate it from part four, if you remember. And the reason why is because it really just all flows. Once you get part three going, all of a sudden you've done and you've solved it and you've got your answer. And so as you're working along, once you hit that optimization part where you do the derivative, that's where you hit part four. But a lot of times I forget to mark that, and so that's really it's not a big deal. So part three and four I kind of tie together. And so what do we want? Well, we know we need the area to be 120 square feet at least. So let's say area, which is the x times y, well, that has to be 120. Okay. Now, like we've been doing in a lot of problems, we solve for y. So let's solve this for y. Well, that's 120 over x. So that's not hard. Now, what do we know now? Well, for blocks, that's y. And so we're going to have 1y, 2y. Okay, so we have 2y. Now, how much do we need? It's going to be that length, but then we have to have it 7 feet tall as well. So we're going to have for blocks, and we'll just do it this way, we're going to have 2 times y, and then that's going to be times 7 feet tall. Well, what's that? Well, that's 14. Well, that's supposed to be a 4. That's 14y. Okay. Well, we just said that this is what y was equal to, so let's go ahead and substitute that in. That's 14 times 120 over x. Okay. So let's leave it with that. That way we don't have to multiply or do anything. We'll just leave it at that for now. And let's go look at our chain link fence. So the link for short, well, that was just going to be our x, which is the length, times, and it has to be 7 feet high. And so, that's, 7x, no matter how do you look at it. So that's 7x. Now let's look at the cost. Though that's how much. Now let's look at the cost. So maybe let's put the cost over here. So cost of the block, and we'll do the cost of the link. Well, the blocks were 50 cents and these were 275. So what we're going to do is we're going to have a 0.5 times 14 times 120 over x. And so if we do that, half of 14 is 7 times that's going to be 840 over x. And this one is going to be 2.75 times 7x. And so that one, I'm just going to do my hand calculator. So 2.75 times, and that was 7. So that's going to be 19.25x. Okay. Now, let's see here. Now we can say, well, if we take this cost plus this cost, we'll get a total cost. So total cost is equal to 840 over x plus 19.25x. And now what we can do is we can say, okay, well, that's our cost. And again, probably we should put this as a function so we know it's a function. So it's going to be c of x total. So now we need c prime of x total. Well, remember, that's the same thing as 840x to the negative 1. So we're going to have a negative 840x to the negative 2 over x squared. And then that's going to be plus 19.25 after we take the derivative. Okay. Now we're going to say, okay, well, let's set c prime of t of x equal to 0. And we'll do this in our calculator. So let's go over here and let's plug it in here. And what I'm going to do is, again, I'm just going to type in my original before I do the derivative. And that way, you know, if I've somehow taken the derivative wrong or something, or really what I want to do this for is I want to see the shape of this and make sure it's the minimize or the maximize and it lines up with my derivative. That's the real reason. But, you know, it also is helping me to make sure I took the derivatives correctly. All right, so that was my equation. Again, I don't know. Okay, so it does work here. So now this is minimizing, and that was what we wanted to do, minimize the total cost. And so now I need to find the 0, and we're going to go on the red. So now we go over here, and that's one end. So let's go to the positive now. We're here. And it says that 0 is 6.606, so let's use that. So we had our shape of the curve was like this. So we are getting the minimum at the 0. So that's what we want. And so we found that then, now we'll put this up here, x was approximately 6.606. And so that is feet because we're doing chain link fence. It's going to be feet. And so now what we want to have, what do we want to have? Determine the dimensions of the dog run. Okay, well, we don't need that many. So let's call that x is equal to 6.6 feet. And that's going to be of what? That's going to be the chain link. And y, well, that's going to be y is equal to 120 divided by 6.6. And again, I'll just do that on my calculator here, 6.6. And we get 18.1818. So it's going to be basically 18.2. And that would be feet. And that's going to be for the block. Okay. All right. And so then if we wanted to, we could take, you know, our 6.6 times 18.2, and it has to be what? It has to be at least 120. Well, it's going to be 120.12. So area is equal to 6.6 times 18.2, and that's equal to 120.12 feet squared. And so we're over that magical 120 number. We've got all of our fences being 7 feet tall. And so this is going to be the lengths of the sides. That's our dimensions that we need. And if we go back over here, we can say, you know, that the block was the 18.2 feet, and this is 18.2 feet, and this was 6.6 feet. And again, not to scale. So, you know, that's they've done it too. It's just how it works. So that's what we have here. Okay, so that's, we determine the dimensions of the dog run that'll minimize the cost, and that also fit that 120 square feet and 7 feet tall. All right, that's all I have for this one. I'll come back with another one.